Hello everyone, welcome to this webinar on building massively scalable CAD configurators. We'll be starting with a webinar right now. So we have pre-rendered our webinar session for smooth delivery of this content, and we encourage most of you to uh, send as many questions as you have in the chat box. We will be monitoring them throughout this webinar, and if necessary, if needed, we will pause the content delivery of this webinar and take up your questions immediately as and when required. And if not, then we would answer all your questions at the end in the Q&A session. All right, so we'll have a live interaction session at the end where we will enable uh, discussions. But for now, we'll start with the pre-recorded, pre-rendered session, and feel free to keep asking questions to us.
Hi, welcome attendees. In today's edition of webinar, we'll be talking about CAD configurators. They have existed for quite long. They were tied to CAD softwares actually. Today, we'll be freeing them from the desktop as well as CAD softwares. Me and Subhranshu are planning to show you how old configurators, if any, can be migrated to cloud and live their life with more freedom, which means reachable, secure, easier to operate, and with minimal cost. I, Name Kumar, Head of Consulting Division at CCTech, and Subhranshu Mazi, my colleague, Head of AI and Forge Division at CCTech, would take you through this tour. We are passionate about technology, and you guys are free to reach out us for any coffee discussions on LinkedIn. So what we'll be discussing today? We'll be discussing what are CAD configurators, why do we need them? We'll also talk about a small fable, in which we try to tell you the story of a configurator. And in that, we'll take an opportunity to actually go through stages of the product development, like design automation on desktop, how do we move that to cloud, and then we have a solution in the industry called Autodesk Forge platform and how to shift to that. And at the end, we'll actually scale your solution to something massive. We'll also be talking about some case studies, and we'll give you the recipe for how this massively scalable web configurator can be made on AWS. So, what is the CAD configurator? You would have already seen some of these varieties in your company. In marketing division, they use it for some other purpose. For commercially, access to these web-based configurators are available. Similarly, technically, making a home or doors can be used. And sometimes a lot of products are actually used internally in the companies, so they're also very helpful. I'll actually show you a very simple CAD configurators. The other configurators which you show on the right side of the screen, we would actually be covering that in the case studies. But let me show you a very simple one. Uh, this is a web-based configurator where you can actually configure a door. You can change the dimensions. You can change the colors. You can actually change colors of parts of the door. So this helps people to actually connect what kind of doors they would be getting. I know this is a simple one, but I think it should satisfy the purpose of what a configurator can be. Moving forward, so previous ones which I showed you were more towards to get the hang of what CAD configurators are. So these are softwares which actually help you to connect your blocks. What kind of blocks? If you see this, the current screen, there are many types of configurators. In enterprise, it depends upon where you are using these configurators, and based on that, there has been naming, some names have been given to them, like knowledge-based engineering solutions, ERP configurators. But in general, I'll not go into much details about this. There's a link below where you can actually go through the whole slide and the details of this. But in general, whenever you would make a configurator, you would actually be solving some blocks of this diagram. Okay. So why do we need configurators? As you would have realized, if you have something which is on web, or even if it is not on web, and it's not a general purpose software, so usually there are very less inputs, and it generates it and it gives you the output. So if there is a requirement which has been raised from the customer, because it's a custom software, it reduces the quotation lead times. And because it's a custom software designed, hence you can actually generate drawings and 3D models and reduce order lead times also. So overall, there is a reduction in cost. Because these custom softwares can be hosted on web, there is a very good chances that people would reach out from web, and hence the market size also phenomenally increases. While we are automating this your whole workflow, there's a lot of elimination of the rework. Usually it is done when we are using a generic softwares, generic CAD softwares. Let me tell you a fable of developing a configurator. Yeah, it's fiction, but it's not very far away from non-fiction. So, in a town of Haiti, there was a massive storm. It actually destroyed a lot of, and there was power was lost. So, the mayor of Haiti actually asked companies to actually submit a proposal for creating a portable power plant. So here enters Joe of Pat Dynamics. He submits a proposal, but before, while submitting, there were some errors and there were some changes that happened which needed some rework. So he had to submit the proposal again. Why he lost the deal? Because there was another company called Future Corporations where Samantha actually visited the site. She actually discussed with the team at Hayati, quickly configured something on her laptop, and was able to actually give the quotation on the same spot. So how configurators helps you is able to win new future deals. And you would have understood Joe discusses with his higher management to invest in creating a configurator so that they do not lose future deals. Let me hand over this to my colleague Subhranshu. He will take you through the next stages of configurators, which is more detailed in the making of configurators. Subhranshu?
Okay, thank you, Neem. And once again, hello everyone. So I will take you through this various versions of a CAD configurator, starting from the traditional variants to the latest and modern technologies based CAD configurators. Okay, so we'll move step by step. Before we go ahead and understand the various types of CAD configurators, first let's try to understand the example case that we will be using to understand all these various versions of CAD configurators. So in this use case, we have a requirement of automatically creating piping layouts, let's say for a factory or so. Okay, so here what we see is a very complex set of piping layouts that is being designed. In a traditional environment, the CAD engineer is supposed to think of the right layout and then use primitive operations of a CAD software to create this whole layout in this software. But in this particular use case, we are expected that automation software is going to replace the whole operations and the thinking also of the design engineer. So the design engineer's thinking as well as the actions in this CAD software is automated through this software. So one thing is definitely automating the operations that is done using the APIs available in the CAD software. But finding the optimal layout design is something that is beyond the scope of a CAD software. If we want to offload the intelligence of the CAD engineer into a software, then in that case, we have to create a custom software where the using generative design, we can go ahead and evaluate multiple designs, create a lot of designs, and then evaluate the effectiveness and usability of those designs, and then based on those scores, we pin down to a final solution. So that kind of computationally expensive algorithms has to be written. A custom made application has to be created along with the consumption of the APIs that is provided in this CAD softwares to create those piping layouts at the end of this process. Okay, so that's pretty much the complete use case that we will be speaking. So here in the first stage of or first version of the product, which is a desktop based automation product, here you will definitely need to create a plugin which goes and installs inside the CAD software. In this use case, we are showing the snapshot of Autodesk Inventor, and here plugin has to be created for Inventor, most likely in C++ or C Sharp. And then this plugin will have its own user interface inside the CAD software, where very less amount of input is asked to the user in order to create the piping layout. Something like the endpoints has to be fixed. That cannot be a part of optimization process. So user will have to at least provide us the endpoints of the pipes, and then our application will first identify or figure out the best layout possible for the constrained endpoints, and then and in the constrained 3D space, and then our application, once identifying the final design, the application will automate the creation of this whole 3D assembly using the APIs provided by Inventor. Okay, so the plugin is required. User interface has to be designed in which very minimal number of inputs have to be asked from the user. All the operations of creating this layout and all will be performed using design automation through within the Inventor application. And the most importantly, since it is a optimization study, multiple designs will be created and then they will be evaluated and finalized, and the final design will be selected. So this whole operation will be computationally expensive, and it's kind of a solver that we are creating. So that also has to be created, and that will be computationally expensive. And since this is all running inside the user's desktop computer, one thing is definitely a 3D environment is loaded. So the 3D software itself is consuming a lot of resources. Along with that, a lot of computationally expensive algorithms are running to do those number crunching and come up with the best design or best layout. And that is also expensive in terms of the computational resources. So it needs a very powerful computer and also a license of the CAD software. So if we look at the benefits, of course, it saves a lot of time for the engineers who are involved in this process. So a lot of cognitive load is being transferred to the software from the human engineers. It speeds up, it reduces the time, it would lead to reduction in errors as the whole process is automated and repeatedly the code is running, so no human errors is expected in this process. It would need very less knowledge to use the plugin compared to the complete CAD software. Remember those primitive operations like creating 2D sketches and then creating revolving operations or extrude operations and all. So those kinds of operations are also not needed when we use a CAD configurator, right? Of course, these are the benefits. Now let's look a little bit on the diagrammatic pre-presentation of this whole workflow. So inside Autodesk Inventor, we will create a custom plugin and we'll develop this plugin, and then this plugin will have its own user interface, and it will be running inside the Inventor application to capture all the inputs from the user, and then the process will then internally start a separate application which is a headless application, and that will do all the number crunching, so to optimize the piping network. And once the finalized design is selected, then this application will use the APIs of Inventor to automatically create the final assembly layout. Okay, so that's how it is going to work. I have also shown some type of the type of compute resource and memory it needs for to run this application successfully. Right. So what does that effectively mean to us? So what it means is the people who have license to Inventor and also have a powerful computer can only take advantage of this type of a CAD configurator. Right. So other employees of this organization would definitely be not satisfied with this kind of a technological solution. Right. So that's pretty much what we are saying here. Also, being a desktop computer being used here in this case, it cannot be massively extensible, and hence even the optimization jobs will take around 6 to sometimes it may take up to 24 hours. So that's not that productive, isn't it? So even though it saves, it's better than having nothing, but there are so huge limitations to this kind of approach. So we can see that the biggest bottleneck here is the optimization workload, which is running on the desktop PC, and we having limited resources on this desktop PC, that is consuming a lot of time. So that's the biggest bottleneck here. And if we want to change that or in the next version of our product, then we need to run the optimization workload on a HPC machine instead of a high performance computing machine instead of a local desktop to reduce the majority of that time that is consumed. Right. So that's what we name it as partial movement to the cloud. That's the second stage or second variation of the product CAD configurator. So here, largely the things remain the same. What changes is the compute resource. The compute resource is not that local desktop computer anymore. The optimization workload is now being sent to a server somewhere in the cloud, and that is consuming 10 HPC computers, let's say, for example, to increase the speed by multiple times, right? So that's the only difference between version 1 and 2. So what happens here is it will now take between 30 minutes to 2 hours for the optimization study to perform, and then we'll come back again to the local desktop computer inside the CAD software and then use the APIs to create the final design. Okay. Now, the users can run this application from medium configuration laptops as well, where they have enough resources to start a CAD software. Right. So the board diagram changes like this. Instead of using starting the optimization workload computation on the same computer itself, we now have the designers in design engineers desktop PC on the left, and we have AWS cloud on the right. You can say AWS or Azure or any other cloud service. So there is a network internet call happening, and the data is transferred to the cloud service, and inside that we are running really powerful computers and a fleet of computers to achieve our number crunching and all. So finally, we come back and on a smaller computer with just 4 cores and 8 GB of RAM, that would be sufficient to run the Autodesk Inventor application, and a finalized layout will be automatically created. Okay. So how that benefits us is people with a smaller compute power and only having license to Inventor can now perform these studies, and the whole automation process is now available to them also. So, since it is now available on a smaller compute environment, users with laptops who have access to Inventor licenses now will be able to use this service. Since it is running on cloud, both of them will be able to perform their jobs, but who do not have a license to Inventor may not be able to use it, even though they have the required computer and all. So that's one of the limitation. That is the limited number of licenses to the CAD software. Only a few people, only a few employees from the design department would be able to use this application. Also, there is no database or data management system available. So in this kind of a CAD configurator, the final results that you get, they have to be manually maintained. The versions will be have to maintain the designs that you are creating day by day. All of them have to be maintained manually by the design engineer only. Right. So these are the two primary limitations that we can see in the second type of a CAD configurator. So what we need next is, of course, we need this kind of a solution to be provided to larger number of employees in the organization. So that is one of our need. And then the application needs to be freed from CAD licensing limits. So that's another requirement that we should next go for. So that's when we take advantage of this interesting platform that Autodesk has built. They have named it as Autodesk Forge platform. This is a cloud service that Autodesk is providing to do all kinds of CAD operations in the cloud. Okay, so we'll see how it works. So what we are saying here is we can now create a browser-based CAD software type of thing, which is not a desktop application. It does not require any CAD licenses, CAD softwares. So directly go to your browser, type in a URL, 3D application pulls up, and there you can provide those small inputs that is required to be given by the design engineer. And then when you submit the job, it will go and perform the optimization studies in the cloud, and then use the Autodesk Forge platforms services to create the design layouts in the cloud, inside Autodesk cloud, and then bring down the visuals for you so that you can see it in the browser. So now many users can run this application from even their tablets or phones, because they do not need a CAD software anymore. You just need a browser with a good amount of screen size. That's all. And hence all employees will be able of the organization can be able to use this application. Either they are creating designs or they are consuming the final designs that has come out of this application. So in your value chain throughout the supply chain, you many employees will be using it for many different purposes. Right. So the diagram gets a little bit complex here, but I'll run through them. It's not that complex as you see. So what happens is this is the design engineer's device. This is the primary device. It could be a phone or a tablet or even a laptop. So browser is being running, and inside browser the application starts, and of course it's a browser based application, so it will be hosted in a web server somewhere, let's say in AWS. So the application is pulled down to the browser, then you are providing all your inputs in the browser based application, and using those by taking those small inputs from the user which is required, the application goes to the backend, the inside the server, and runs the heavy evolutionary algorithms to generative algorithms to optimize the design, and then select the best design. And finally it goes to Autodesk Forge platform, where using their services, we are creating the assembly design, assembly file in inventor format, and finally that assembly is managed and maintained inside Autodesk Forge. So there is no chance of getting them deleted or something. They will be maintained for you by Autodesk. And finally, you can see that model in your browser when the services are completely in the processing. So once this inventor is automatically inventor has created this assembly designs and all, that file can be pulled down to the browser and viewed by the design engineer. So this is how the whole cycle of process is going through. Okay. So what happens to the employees then? The employees, all of them are able to use the application, because either you have a desktop PC or a laptop PC or even tablets or some new devices. You have browsers, and in browsers you open this application and do the study, uh, do those computationally expensive things on the cloud, and using Forge platform you also create the assembly files in the cloud itself, and you do not even worry about the licenses, and it's as much as consumed as per the consumption, the Autodesk Forge will be charging us the invoices. So there is no need of inventor licenses to be installed on these softwares, on these computers, and you get the designs loaded in the browser itself. But the challenge here is, or the limitation here is that since the cloud infrastructure is limited to 10 HPC instances. Remember, at the start, we decided that we'll go with 10 instances only. So they are huge servers, but they are only 10 in count. And that is the reason when lots of people start using this service, their jobs are expected to go into queue, because as we remember some time back we saw that uh, in a desktop computer it was taking around 6 to 24 hours to run these jobs, the optimization jobs. But now it is taking, since we moved to cloud, it is taking around 30 minutes to around 2 hours, depending on the size of the job. So if one person's job is consuming up to around 2 hours, then not many can be running their jobs in parallel. Someone, if there are lots of users coming and using this application, then they are their jobs are expected to go into queue, right? So that is now the next set of limitations that we need to free from. That's pretty much the limitations that we just now discussed. One good thing is that since we are using Autodesk Forge platform, you do not have a limitation of the CAD licenses that is needed to create the final assembly files and all in the cloud. So that part is very well taken care by Autodesk systems, Autodesk Forge platform. But the computational job that the optimization workload that we are running outside the CAD software and all, that custom algorithms that are running, that needs to be also scaled up massively, so that there is no queue or no waiting time to be used. Right. So that brings us to the last stage or last variation of our CAD configurator, which is massively scalable configurators. So here what we do, most of it remains the same. The application still is running in the browser, and the backend now has a scalable infrastructure. That's pretty much the difference that needs to be done. So how we are doing it? Let's see that. So we will be creating a full-fledged application which will take care of multiple things, not just the infrastructure that needs to be scalable. Along with that, there were other requirements which also needs to be satisfied. Like since it's a product, the users would expect that I log into the application through my organization's login system. So a good login management system has to be there. Then since I am logging into the application over and over again, I'm expecting that my old designs and all should also be maintained in the application in the cloud itself, right? So that I can go access this application, go back in time and see all my previous projects, and then maybe clone them into a new project or do something like that. So there has to be a good database to manage all the projects and all. So that kind of a complex application has to be designed. And then what we need to do is we need to scale the infrastructure so that whenever load comes, we spin up new compute environments and perform the workloads. Right. So that's what the board diagram also says. So the major difference is only in these two blocks at the right bottom corner. So we are using scalable infrastructure for all our business logic that is running inside the cloud. And then also the underlying compute hardware that we are using, that also is a scalable infrastructure. So every time a job is submitted, which would take somewhere around 30 minutes to 2 hours, then that job will need a computer which needs to be spin up in the cloud on demand basis, and that computer will be used for run that job. So at that time, no matter how much load comes to the application, how many users come to the application, actively submit jobs, no matter how many they submit, those many compute environments will be spin up, and they will be used to run those jobs. And once that job is completed, we again uh, terminate those instances. So that's how a scalable infrastructure is created. So what I'm saying here is just like Autodesk Force takes care of the whole scalability of no matter how many assembly files that you need to create, you can just submit those jobs and they will take care of the infrastructure. They will spin up machines, they will spin up licenses and they will pull up licenses, and they will take care of it so that your designs do not stay a lot of time in the queue. So similarly, we have also created a similar infrastructure inside AWS or any cloud provider to also run your compute heavy loads. Okay, so this solves the problem for all employees. So all the employees are now submitting jobs as and when they want, and in real time, whenever the demand comes, we are able to spin up more resources in the cloud and satisfy the amount of workload that has been requested. So no more limitations. Forge takes care of the license limitations, and AWS or any other cloud infrastructure, they take care of our compute resource infrastructure. So what we have achieved is highly accessible and scalable CAD configurator made possible using Forge platform and also serverless cloud services. The running cost is extremely low as you would only pay for what you consume. No maintenance, as the application being completely serverless becomes cloud providers' responsibility to look after the infrastructure. Reduction in time in development of newer features, because we are using very well designed services from the cloud directly in our application. The development time reduces pretty much. All right, so too much of theory. Now let's go ahead and have a look at few interesting CAD configurators that we have created. So this is desktop-based CAD configurator or a CAD automation project. So you can see how easily through some drop downs we are able to fill the details of a CAD model. And the moment we say generate model, it's directly creating those models in the solid edge software. It's one of the most basic needs of a CAD configurator to automatically create components which are part of a template or a particular uh, business line. As you can see, it's very simple inputs, and when you create these from those simple inputs, you are able to create these complex engineering drawings, bill of materials, and all. So that just tremendously increases the speed of delivery of these kinds of documents. Okay. So the next one is how to use a 2D layout creator to design plants and all. Uh, let's have a quick look at that. So this is a custom requirement where you are overlaying the maps and a 2D sketcher together in the web browser to create these kinds of layouts, industrial plant layout and all. So very highly customizable 2D sketcher where you can create these kinds of layouts, and that too it is overlaid on the map to see the real visuals of that location and to identify and understand the size of the industry that is to be put into place. Right. So the next one is AI-powered design optimization of a valve, typically a triple offset butterfly valve. So here, what you would see is this is a CAD configurator because you can see the parameters which, when changed, the design of the control valve will be changing. So through the primary parameters of the butterfly valve, we are able to create new designs through just simple sliders. But there is more to it. Here we are also doing something called as we are using artificial intelligence to predict the performance of the designs. So there was a sample set. We did CFD on in that sample set, and doing those fluid simulations, we were able to then learn from it, and then we were able to answer the real question that designers need, which is in order to achieve a particular type of performance, what should be my design? So instead of creating a design and then quickly guessing or predicting the performance of it using this kind of a CAD configurator, we are able to answer the reverse question, the one which is really required. I want a certain type of performance, and how well, which design is the right design to achieve that performance. So here you can see I'm changing the sliders, and the designs are getting generated in real time. Um, and also its performance is being predicted. But in the reverse calculation, um, yeah, let's see. Yeah, here. So here when we are changing the performance, we are now doing the optimization study, figuring out so many solutions together, and then pinpointing to the right design, which is the closest match to the required design performances. So it's a very two-way use case is what I can say. So we have already seen this demo at the start of the webinar, Usually what is happening here is, imagine a door manufacturer has set up this CAD configurator in the web and provided this to their customers. So the customers are visiting their website, designing their own doors, and finally they are submitting the design and doing the purchase in the website, and the full automation in the backend is happening. The design documents are getting generated, the bill of material is getting generated in the cloud and the backend, and finally in the e-commerce portal or the logistics platform that they have in the company has, they are getting this order generated, and also payment gateway being integrated. The customers are also able to do the payment upfront and uh, uh, register the request of manufacturing. So the manufacturer then, using these designs that are generated by the customer, they are directly using these designs to manufacture, and the number of quantities of these doors to be manufactured is also being taken from the user. So it's a end-to-end solution for the users directly. They go into the website, interactively design the door, and then directly place the order, and they track the order, and finally the orders get delivered to their provided address. So it's a full end-to-end system. We are working with customers who are door manufacturers, who are railing manufacturers, and such other types of construction industry use cases. We directly develop these kinds of fully connected platforms where users can design their products and then automatically uh, place the orders and do the payments, track the packages, and get them delivered. Then this is an interesting use case. Here we have a 2D sketcher created in the web browser. This is a part of our Simulation Hub web platform, the product that we have for our AEC industry. This is a SaaS-based product, Simulation Hub. Here, the name of the application is Autonomous HVAC CFD, where we are providing this 2D sketcher to create building layouts, building spaces. And here, the designs, after creating the designs, we are adding furnitures, windows and doors and everything to the layout in the web browser itself. And finally, after creating all this in 2D visuals, you are now then able to automatically create the Revit file of this model. And since it is a part of Simulation Hub, you would see we are also doing HVAC components. We are adding HVAC components to this sketcher here. Yeah, these are the HVAC components. We are placing thermostats, yeah, the air side components will be then placed, the supplies and the returns. So it's an office space which has been designed through the sketcher, and quickly the user is able to insert the HVAC components into the this office space. And a lot more settings related to the thermal properties of the HVAC system that are being asked to the user. And finally, this, you can see this beautiful Revit model is generated automatically without any intervention of the user. And the user is then able to submit the fluid dynamics simulations and see the flow distribution in the whole space using that thermal uh, design, the HVAC design that has been that was created. So here, yeah, some visuals of the results also is now demonstrated. Which person would experience comfort and which would not, and all. The thermal plumes, the visuals, the temperature plots and everything is then visualized in this application. So this is all happening in the cloud, and these are all happening using, first we saw the SketchUp to create the design in a simple way, then taking the custom inputs required to do these kinds of fluid simulations, and then the visuals are also being loaded into the 3D model and in the 3D environment itself with beautiful animation. So that's the way really customized CAD solutions are the need of today, and those are only possible if we move out of traditional CAD softwares and go into cloud, then use this Autodesk Forge platform to get these kinds of automations possible in the cloud, and using all the cloud resources to do mammoth amount of these kinds of CFD workloads or optimize and design optimization workloads to achieve better designs. So today we are into a very beautiful time where all these kinds of very custom requirements are necessary for beyond the standard traditional CAD softwares that they offer. That the type of possibilities that standard CAD softwares offer. Beyond that, we need such kind of customized workflows and customized softwares. Okay, so that's pretty much about the use cases. We can now quickly have a look at the architecture that are needed to so what the type of architecture that is needed to create such kind of softwares. So it will be a little technical, but bear with me, it is not that complex to discuss. So generally what we need is the front-end devices that the user will be using to consume these kind of applications. Those could be mobile phones, laptops, tablets, and even desktop computers. Then you will of course need a cloud platform where we uh, set up all these services like user authentication, and then the APIs to manage the backend business logic, then the application, the front end application, which should be delivered across the whole planet. So and that has to be a CDN service. Then logics of the application will be hosted inside serverless functions. Then the computationally expensive stuff will be run on container services or virtual machines and all. Then you will be needing a database to manage all these projects, solutions, results, reports, and everything of the user. So that is also needed. So a full-fledged web application needs to be built, uh, and then comes the um, um, Autodesk Forge platform, where you consume these kinds of services to create 3D models, to view 3D models, and to do some workflow automation inside this platform. All of this is happening in the back end of your application, so user do not even know or get a sense that something is happening, where we are connecting to Forge and then opening some softwares for Autodesk softwares and creating those 3D models or something like that. So all this happens automatically in the backend. So that's pretty much the type of architecture that is needed in order to create such kind of softwares. Yeah, the browser layer, the browser application sits in this layer. Then the business logic sits in the backend layer. Then the CAD workflows are supplied from Autodesk services. Okay, so now the same things when we see from AWS perspective, you get these services provided by AWS in their cloud. If you see it from Azure platform, then you see these equivalent services provided by Azure also. That's pretty much the architecture of how to build such kind of a massively scalable CAD configurator for various customized workflows. Okay, so I think that's the end of the slide deck, and now we would like to directly interact with you through question and answer. Okay, so I would request Neem Kumar to also turn on the camera, and if he wants to speak to the attendees a little bit to add something to this slide deck, we would be interested to hear from you, Neem.
Thanks, Subhranshu. I hope it was enjoyable, and if not enjoyable, at least knowledgeable. So if there, thanks for attending. If there are any questions, I think one question we have from Yash. We'll still request to ask any questions, simple or difficult, or anything you can think of. So Yash, when you said, are there still any areas we could improve upon? Would you be interested in elaborating your question?
Okay, 1 second. Maybe I'll ask to unmute. Yes.
Yeah, hello, sir. I wasn't able to unmute myself earlier. Yes, earlier when we saw that we were building configurators with Inventor, but we had the licensing issues. So we fixed that with using Forge. And then all the earlier issues we had, like only with the 10 possible servers, and then we fixed them each eventually with different technologies. So I was wondering, with the final version of the configurator that we had, if there are still any areas that we could improve upon, and if yes, then what other possible technologies that we can use.
Okay, as for we, at a very high level, we have broken down the application, right? Something which was running and in a very monolithic way in at one location, or one desktop. We broke it into such a way which could be used by multiple people. So multi-user we brought in, licensing mechanism was reduced, the computations was outsourced. So we think for major time, the kind of industry that uh, where configurators can be used, it looks like these solutions should be helpful. Did I was I able to answer your question? Okay. And else?
Yes, sir, that answered my question. I had one more. Can we use any other softwares other than Forge? Maybe some engines out there like Unreal or something to build configurators, and if there are several possibilities of making them web apps using AWS, maybe we can use those too.
Yes, very good question, Yash. So many other softwares actually, so Forge actually provides lot softwares which are from from AutoCAD, Autodesk background, but many other like PTC or Onshape, they've also making their own relevant CAD softwares, and connecting to those CAD softwares, their codes people are writing to make them as configurators. So possibilities are high. At a very low level, what actually can be done is, you can actually use a 3.js or these kind of geometry based libraries, and you can actually use that to build a very simplistic CAD software. It cannot be used to actually build a very complex one, because to build a CAD software on cloud, main components, what you need is actually the graphics library, Then you need something called solid which actually provides you solid modeling tools. uh, the third is, while you would have recognized whenever you are trying to sketch something, it actually solves some constraints. Once you make a rectangle, you put that intent on a rectangle. It's a rectangle, and if you want to drag it and if you modify it, still it's a rectangle. So that portion is actually done by constraint solvers. So these are three, I would say, very low, very important components, which are actually required for a full-fledged CAD software. But while you're making something on cloud, you definitely can abstract out, because one very good thing which we saw in all the examples was solving specific things, not a very generic ones. So when you know that you're making a door configurator, what kind of constraints you want, so you can actually write code for that. So definitely, you can do a lot by building from scratch using 3.js level libraries also.
So, thank you.
Thanks, Ish. That was a good question. I think it might be relevant to many other people. Anybody has questions, if you can just put on chat, uh, or we can actually take that question from chat. Okay. Maybe as we said at the start, we are available on LinkedIn, and if there are any questions which you want to post, we will be you will be able to easily find us. And if you let us know, we can also reach out to you. That also is a possibility. We can actually write our email IDs here, so that if someone wants to email and ask questions, that will also be helpful. You can also let us know any feedback about this webinar, and any suggestions you have, any newer topics you would be interested in. That will also be helpful. We are thinking to start more of more webinars or blogs on these interesting technical topics. So please do you know message us or anything. So Shubhranshu, I think should we call it off, because or we want to ask, because I can see from the list we have Digesh here.
Okay.
Yes, sir.
Okay, I have a question. We have a question. Does CCTech also talk about UX design? Okay. CCTech in general is an organization which actually is into digital transformation. So digital transformation needs connecting systems, right? And when you're connecting systems, there would be people or users who will be using the system that you design. So when people are involved, UX design is there. I hope that solves the question. Whenever softwares are there, then that needs to be done through definitely some UX level designing. The more the complex interfaces are, the more it has to be simplified, to break down into different workflows. So yes, definitely, UX design is an important part. And how can I unmute myself?
Okay, now you can.
So basically, I did my bachelor's in product design and now I'm pursuing my master's in UX design only. So I had this question like having this webinar, like talking about digital transformation and also like from code tech perspective, also like the UX design comes hand in hand, like it can't be neglected. So this was curious about do company also like bother about UX research and like making a better experience and also. So like my major question is like, can we have a webinar on UX designer as well? Like if someone in the company works on that. So
Yes, I think definitely we have people on UX design, and so a good suggestion. We'll put into the list and come up with something which is there are many things actually in UX design. Maybe we can connect with you what specific you're looking, or at a very high level, it could be started from something generic.
yeah. Also like, do you guys provide internship?
Oh yes, definitely. I think you can reach out to us on LinkedIn. We'll actually direct you to the right people who would actually, will take internship.
Oh, okay. Can you just post your LinkedIn profile in chat box?
We have posted emails. I think email would be also a good one. I think you can post your resume and your intent in the emails that we provided.
Cool. Thank you.
Sure, thanks.
All right, I guess we would then call it an end to this webinar. Thank you everyone for joining this webinar and hope you enjoyed this webinar. Stay connected with us and have a good night.
Thanks a lot, guys. Bye-bye.
Thank
Bye.
you.
Thank you, sir.
Bye.